Hello there, I'm Raiaan from Roots of Unity, and today we're going to talk about polar coordinates. So, what exactly are polar coordinates? Now take a look at something we already know about, which are Cartesian coordinates. Well, even if you're not familiar with the name, if you take a look at the diagram, you'll understand what I'm talking about. Basically, let's take the point C, right? And let's label this 1, 2, 3, 4. That's the x-axis. And here's 1, 2, 3. That's the y-axis. Now, when you refer to the point C, how are you going to call it? You're going to say 4, 3. This is the x-coordinate and the y-coordinate, right? Now, in a polar diagram, we're going to use angles. In the Cartesian diagram, we refer from the origin. Oh, right. For polar, the reference point here is called the pole. So accordingly, let us draw a line here. Now, this angle here, that's the theta, right? That would be, for example, pi by 4. So we have two things here. We have the point and the angle. We don't have linear dimensions as we would in a Cartesian diagram. So here we have the distance from the origin, that is r. You could say that is 5 units. And then we have the angle formed with the x-axis, which is theta. Now, this is used for navigation, design, and manufacture. And you have really pretty graphs. Well, that kind of covers the general idea of Cartesian and polar and how they're different. Also, if you were going to write the coordinates, that would be as 5 pi by 4. So basically r theta. And as you can see, it can be either degrees or in radians, whatever the question asks for. Now, let's take a look at the relation between Cartesian and polar. It's basically a trigonometric identity. So you have the radius here, and then there's the x, and then there's y. X-axis and the y-axis, right? So for x, the relation would be r cos theta. And for y, it would be r sin theta. And we know that x squared plus y squared equals to r squared, as you see over here. There's another way to prove this. So we can bring all of these together. So r cos theta whole square plus r sin theta whole square equals to r squared. Now, if we expand this, we get r cos squared theta plus r squared cos squared theta plus r squared sin squared theta. And we know that cos squared theta plus sin squared theta equals to 1. So, it's as easy as that. Moving on, we're going to look at conversion. Now, let's start from something very easy in polar and when we convert from polar to Cartesian. Now, basically what we have here is r equals to 3. That's the polar equation that we're going to convert. Let's look at the identity we just found out. So that is x squared plus y squared equals to r squared. We take the value of r and substitute. So that would be x squared plus y squared equals to 3 squared, which is 9. So the Cartesian equation would be x squared plus y squared equals to 9. Now, if we're going to draw a diagram for that, it would basically look like this. Wait, hold on. It's going to be a circle. The radius here would be 3, and it starts from the origin. Now, for this one over here, you have 4 cosec theta. First off, we're going to convert it to sin theta. So that would be 4 by sin theta. Now we take the identity to the left-hand side. So r sin theta equals to 4, right? And now we can replace this with y. So we have y equals to 4. That's literally it. And if it's in a diagram, it would just be a line. So that would be the x-axis and the y-axis. And that would be y equals to 4. As easy as that. Now we'll look at another answer. I can pause for a bit if you want to solve this yourself. So, first off, you can see already that there's a double angle, right? So, you already know the identity. Cos 2 theta equals to cos squared theta minus sin squared theta, right? Now, we're going to input that in the equation. What we'll have is r square cos squared theta minus sin squared theta, right? That would be 4, and r squared cos squared theta minus r squared sin squared theta equals to 4. And if you take the squares out, you have r cos theta, which is basically x squared minus r squared sin squared theta, that will be y squared, equals to 4. That's all. Basically, you need to know that you have to get rid of the double angles. And the main deal here is to substitute the trigonometric identities as necessary. Now, let's not get scared by this, okay? You're going to convert from Cartesian to polar. It's also pretty easy. This is really easy. So you have x equals to 5. We already know that x equals to r cos theta. This would be 5, right? You have r here. Now you're just going to make r the subject. So you have 5 pi cos theta, which would be 5 sec theta. That's all. Now this one's a bit lengthy, but we can go through this, it's fine. Basically, we're going to take the x square and convert that to r square cos square theta, and the same goes for y square. What I did here is, you have y square whole squared, so that would be the same here, like r square sin squared theta whole squared. So this is what you have over here, and the part below is as obvious as it gets. Now, then we take the values of the denominator to the other side. So when you expand, you get this, and the right hand side stays as it is. Now we take the cos squared theta here and convert it to 1 minus sin squared theta. Then after you expand, you have this and this. Now you'll see that there's the same value here and here, so you can just cross it off. Then you have r squared cos squared theta minus r to the power 4 sin squared theta. Then you take the common as r square, and we have nothing to do with that. So when we look at this, you have cos squared theta minus r squared sin squared theta. And if you take this to the other side, basically what you get is cos squared theta. That's your answer. So basically the key here is to replace x and y and simplify. As easy as that gets. So x would be r cos theta and y would be r sin theta. And then you need to simplify as the question asks for. That's literally all you need to know about converting from polar to Cartesian and vice versa. In the next video, we're going to talk about how to sketch graphs, and I promise it will be very, very interesting. I hope that was helpful for you, and I'll see you next time. Goodbye.